Hello. This short video presentation is a continuation of what we did yesterday, but now we're going to look at what do we do when the leading coefficient is not 1. Let's look at a polynomial equation. Our equation is 8x squared minus 10x minus 3. What we did yesterday only works if the leading coefficient is 1. So what we're going to do is divide by the leading coefficient. So my equation ends up being 0 divided by 8 is 0, equals x squared minus, and I need to reduce the fraction, 5 and 4, minus 5/4 x minus 3/8. And then just like yesterday, the sum is the opposite of this number, the opposite of that number, positive 5/4, and the product is this number right here. The product equals negative 3/8. So the sum and the product of the roots are the same as yesterday. All we have to do is divide by the leading coefficient. Divide by leading coefficient. That's it. Now, let's look at the other side of the coin. What happens if we know the roots? For instance, let me write the instructions. All right, we want to find the equation whose roots are 2/3 and 5/2. So the sum, now not quite as easy, 2/3 plus 5/2. Common denominator would be 6 times 3 over 3 times 2 over 2, and we get 4/6 plus 15/6 equals 19/6. Product, of course, a little bit easier. Product we have 2/3 times 5/2. Always remember, it helps if we cancel our common factors and we end up with 5/3. If you remember from yesterday, our equation is 0 equals x squared minus the sum of the roots times x plus the product. So my equation is 0 equals x squared minus the sum, 19/6 x plus 5/3. And then we have one last step. We got to get rid of the fractions. We multiply by the least common denominator, which in this case is 6. Multiply both sides by 6. Still going to end up with 0. 0 equals 6x squared minus 19x plus 3 goes into 6, 2 times 5 is 10. And there is my answer. Okay? I'm going to do one more example just to make sure we understand what we're doing. But to go over, we set it up just like we did yesterday. The only difference being it's a little more complicated adding and multiplying. All right? We added together, had to get a common denominator, multiplied, and then our equation was x squared minus the sum times x plus the product. And then what we did at the very end is we multiplied by the least common denominator on both sides. Although because it was 0, the net effect was nothing changed. All right, let's do one more example. All right, our last example is we want to find the quadratic equation whose roots are 1/2 and 3/5. First of all, we need to find the sum. 1/2 plus 3/5. Common denominator is 10 times 2, top and bottom, times 5, top and bottom. And we end up with 5/10 plus 3 times 2 is 6/10, which equals 11/10. The product is 1/2 times 3/5. We multiply across the top, 3, across the bottom, 2 times 5 is 10. And then we can write our equation. 0 equals, remember this 0. A lot of people will lose points because they don't actually write an equation. 0 equals x squared minus the sum plus the product. I did that backwards. Minus the sum. Start over again. The sum is 11/10 plus the product, 3/10. And now we multiply both sides by the least common denominator to get rid of the fraction. Times 10. And we end up with 0 equals 10x squared minus 11x plus 3. And we have ourselves an equation. All right. Hopefully this makes a little bit of sense. It's not too much different than yesterday. We're just dealing temporarily with a few fractions. All right. Have a great day, and I'll talk to you guys later.